afternoon, everyone. So in today's class, we'll study an example. Second example, I have already teach you a first example, first problem. So today's is second example. So today's second example for us. Okay. Today we are in second example. Second example is example number 2. Example number 2. So if G is an abelian, if G is abelian, prove that G by N is abelian. G by N is abelian. Okay. So example number 2, if G is abelian, then prove that G by N is abelian. This is question number 2. For the second question number, we'll solve here. Okay. So what G is abelian. So all terms, all group no abelian then prove G by N. G by N is nothing but factor of a group is abelian. G by N factor of G by N. G by N means factor of an abelian. Factor of a group. Okay. Factor of a group is an abelian. Prove okay. So what we all know by the factor of a group is factor of a group. Let n by a if na belongs to nb or you can write like this also, or you can write same like this also. Na and nb belongs to G by N for some a comma b belongs to G. Okay. So what we have considered? Let us see here. Let NA and NB by the these are true by the factor of a group. NA and NB belongs to G by N. For all A comma B belongs to G. So G ಇದೆ, G ಅನ್ನೋ group ಇದೆ. So ಅದರಲ್ಲಿ ಏನು belongs ಆಗ್ತವೆ? A ಮತ್ತು B ಎರಡು belong ಆಗ್ತವೆ. Okay. Okay. So next, let's see the next steps. Okay. So G by N, NA and NB belongs to G by N for A comma B belongs to G since G is an abelian. Since G is an abelian. G is an abelian ಇದೆ ನೋಡ್ರಿ G abelian ಇದೆ ಏನಾದ್ರು ನೋಡ್ರಿ. So since G is an abelian ಇದ್ದಾಗ AB A comma B belongs to G ಅನ್ನೋ actually A ಮತ್ತು A and B belongs to G. This A and B both are belongs to G. For that we can write AB is equal to BA. So both of them belongs to same. So we can look an example. 3 plus 2 is equal to 2 plus 3. Okay, is equal to 2 ಮಾಡಿದ್ರು 5 ಬರ್ತದೆ. So or 3 into 2 is equal to 2 into 3 sorry. So ಎರಡರ ವ್ಯಾಲ್ಯೂ 6 ಬರ್ತದೆ is equal to 6. So ಇದೇ ತರ A equal to AB equal to BA ಅಂದ್ರೆ A equal to B ಅಂದ್ರೆ is equal to BA. ಒಂದೇ ಫಾರ್ಮುಲಾ Okay. So this is how we write this. So now by considering, now what we consider here, now by considering now consider, so now we can consider, so Na into Nb, Na into Nb, Na into Nb, Na into Nb. Now we consider Na into Nb. So I'll write here. So what we write? Na into Nb is equal to Na bracket of A into N into B. This is how we write. And so next N into N into AB, because we write this because so the art G abelian, where G is abelian, right coset is equal to left coset. Right cosets is equal to left cosets. Okay. N equal to Nb now. So we can say that N into N is equal to, what is the property? N into N is equal to only N. So N AB. So N AB because so we know that N is equal to N for N is normal value. N is normal. N into N is a normal here for us. Normal. So we write N is equal to N. Okay. So understand for the first step till this. Okay. So what I said first, first I will say. So what I said, if G is an abelian, then prove that G by N is nothing but factor of a group. Factor group is abelian. What question is if G is an abelian, I mean prove factor of a group is abelian and prove. Okay. So what we consider for that? So factor of a group and again prove factor of a group and prove. So what we say that what we took Na and Nb belongs to G by N. So by the values of factor of a group, we took Na and Nb belongs to G by N for all. So Na and Nb belongs to G, the A comma B belongs to G directly because Na A and B belongs to G by N. So directly we can say that A comma B belongs to G. Since G is an abelian, A comma B also belongs to G. So we can write AB is equal to BA. I said you example 2 plus 3 is equal to 3 plus 2 by the properties of groups. So after that we consider the values Na into Nb, N into An into B. So this is by the right coset is equal to left coset. Now directly notation and the so we will write interchanging this N into N AB. Okay, N is equal to N by the normal subgroup of it. NSG. NSG is nothing but normal subgroup. So is equal to NA. So I'll take next page. Okay, next page. So till what we have done? N into NAB. NAB. Therefore, we can write so NBA. So NBA hang barkonadra. The reason AB is equal to BA. So marrying by the first we have done above this. For that we are writing. For this we are writing AB is equal to. Therefore we can write AB is equal to BA. So name textbook name put from the equation 1 ಅಂತ ಕೊಟ್ಟಾರ. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ equation ನಂಬರ್ ಬರೆದಿಲ್ಲ, ಅದೇ equation ಬರಲಿಲ್ಲ. ನಾ equation 1 ಅಂತ ಬರೆದಿಲ್ಲ, ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ AB is equal to BA ಅಂತ ಬರೆದಿದ್ದೀನಿ ನೋಡಿ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ by this we can write, so we can write that n is nothing but n into nn dA. Okay, nn dA. By we are doing for next for reverse method ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ, ಮತ್ತೆ reverse ಮಾಡ್ತೀವಿ. ಅಗಲ ಸ್ಟೇಜ್ ಬಂದು, so next reverse this into A. Okay, so nb is equal to, so next n into b into n a. Same ಇದು ಯಾಕೆ ಬರ್ತೀವಿ ಅಂದ್ರೆ ರೈಟ್ ಕೋಸೆಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಲೆಫ್ಟ್ ಕೋಸೆಟ್ ಇರ್ತಾವ. ಸೊ ಅದಕ್ಕೆ ಇದು ಬರ್ತೀವಿ ರೈಟ್ ಕೋಸೆಟ್. ಜಿ ಅಬೇಲಿಯನ್ ಗ್ರೂಪ್ ಆಗಿ ಏನಿರ್ತಾರೆ, ಅಬೇಲಿಯನ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ರೈಟ್ ಕೋಸೆಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಲೆಫ್ಟ್ ಕೋಸೆಟ್ ಇರ್ತಾವ. ಓಕೆ, therefore right cosets is equal to left cosets in ಎಲ್ಲಪ್ಪ ಅಂದ್ರೆ ಯಾವ ಜಿ ಅಬೇಲಿಯನ್ ಇದ್ದಾಗ, when in G is abelian ಇದ್ದಾಗ ಅರ್ಥ. ಓಕೆ, G is an abelian matrix. Okay, so therefore that is NA into NB is equal to NB into NA. So for all NA comma NB belongs to G by N. Okay, G by N. Hence G by N is abelian. Since G by N is abelian. Okay, you got this? So once again I'll explain you from first. Okay, so example number 2 we are writing this. If G is an abelian, so statement in the question is, so if G is an abelian, prove that G by N is nothing but factor of a group is an abelian. So next note, let NA and NB belongs to G by N. Okay, you already know that by the factor of a group we have NA and NB belongs to G by N, or NA and NB is equal to G by N. So for some, therefore A comma B belongs to G. So yakandra A, NA ಮತ್ತು NB ಗಳನ್ನು directly we can say that A comma B belongs to G. Since G is an abelian, so we can say that A comma B belongs to G. So we can write that AB is equal to BA. So now considering NA into NB is equal to N bracket AB. So N bracket AB is the next ಇದು interchange ಒಳಗಡೆ interchange ಯಾಕಂದ್ರೆ G is abelian ಇದ್ದಾಗ right coset is equal to left coset ಆಗಿರ್ತಾವ. ಯಾವಾಗ G is abelian ಇದ್ದಾಗ ಅಷ್ಟೇ ಆಗಿರ್ತಾವ, right coset is equal to left coset. Okay, so we can write NNAB. So we know the value of NN is equal to N. ಯಾಕಂದ್ರೆ N is normal ಇರ್ತದ. So next step ಎಂದರೆ next step is equal to NAB. So interchange ಮಾಡ್ತೀವಿ. ಈ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಾಗೆ equation 1 ಏನು ಕೊಟ್ಟಾರ, ಸೊ ನಾ equation 1 ಏನು ಬರೆದಿಲ್ಲ, ಸೊ ಡೈರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರೆದಿದ್ದೀನಿ AB is equal to BA. So by this we interchange the values of like this. So next, so by this we can write n is equal to n ಅಂತ ಬರೆಯಬಹುದು. So n is directly now we write this process NNAB. So next here also we write interchanging the cosets of right coset is equal to left coset. ಎದಕ್ಕೆ ಬರ್ತದ ಅಂದ್ರೆ G is abelian ಇದಕ್ಕೆ ಬರ್ತದೆ. So we can write NB into NA. So NA into NB is equal to NB NA for all NA comma NB belongs to G by N. Hence G by N is an abelian. Okay, this is our second example. Okay, this is your second example. Now we shall start with third example. Next we shall study the example number 3. So this example is not so important for you. So which are the important examples I will say to you. Bit important, but for your internals, bit important for you. So if H is a H is a subgroup, H is a subgroup. If H is a subgroup, if H is a subgroup of index of index of index 2 in a group G in a group G in a group G in a group G, then prove that H is a normal subgroup. Normal subgroup. Normal subgroup. Okay, of G. So, what is your question? So, question answer. If H is a subgroup, H is a subgroup of index 2. So, it is having an index with 2 and in a group G. Okay, then prove that H is a subgroup of a normal subgroup. So, H is a normal subgroup. So, the index is 2. Index is 2. In group G. H is a normal subgroup. Subgroup of index 2, then we have to prove normal subgroup of G. Okay, so we must know the definitions of index. So definition of index, I think you have studied. So definition of index. So definition of index is let G be a group. Let G be a group, and H is a subgroup. H is a subgroup. H is a subgroup. H is a subgroup of G. H is a subgroup of G. Defined in the index. Defined in the index. Defined in the index. Defined in the index. Defined in the index of H in G. Okay. Defined in the index of H in G. That is number of distinct right cosets. Number of distinct this is distinct right cosets of H in G. Okay, so it is denoted. It is denoted by very important index. One second. So it is denoted index of H in G. Okay, alright. This is how we write index of H in G. This is how we denote this. Index of H in G. Okay. Index of H in G. Okay. So next, it is denoted as next. Index of H in G is equal to. So, hang find out what game system so number of distinct right cosets distinct right cosets, only right cosets, not really. Right cosets H in G. So if they ask you for important index, definition of index, important for you. So exam check here. So define define index of a group or index. Let G be a group and H is a subgroup of G defined in the index of H in G. That is equal to number of distinct right quotients in H in G. So that is index of H in G is equal to number of right quotients H in G. So it is denoted as index of H in G. This is how we remember. This is a definition of right. This is a definition of index. So group will find out, if you want to find out a H in G, group will find out, you must calculate the different cosets. So you value. So index of 2 value. So so you must calculate the different cosets. So if right coset is equal to 2, right coset 2 is equal to 2 if we have right coset is equal to 4 4 so in right coset same define define in the index of define okay. So next we will go for this problem. Next we will go for this first problem. So next we shall study the solution for this. Okay, solution for this. Okay, this is a let G be a group. Let G be a group. Let G be a group. Let G be a group and H is a subgroup. And H is a subgroup. Okay, H is a subgroup. Let G be a group and H is a subgroup. Subgroup. That is what they have given for index of H in G is equal to value in the 2 and 13 okay. We know the value of index of H in G is equal to 2. Okay. Therefore, so there are only two distinct right cosets. Okay. There are only two distinct right cosets. There are only two distinct right cosets. There are only two distinct right cosets of H in G. Okay, we got the values. So here are H. Index of H in G is equal to 2. There are only two distinct cosets. Right coset only two distinct right cosets. Okay. So next, we have to prove that H is a normal subgroup of G. We have to prove that H is a normal subgroup of P. So now to prove. So next H in G. So next G can be expressed in the form of G can be expressed expressible as union of two right cosets. Okay, so I'll explain this first. After that, I will go for the next steps. So I'm again prove that G is a subgroup of index 2 and in the group G, so in the subgroup of index G, index 2 in a group of a G, then prove that H is a normal subgroup of G. So now subgroup of index 2 kotara, so now in prove normal subgroup in prove. So first I got it to let G be a, as usual, let G be a group and H is a subgroup. So what they are given? Index of H in G is equal to 2. Index of H is either meaning there are only two distinct right cosets in H in G. The value there are only two distinct right cosets in H in G. So G can be expressed. So in the G and union of no express market. Okay. So I'll go for next page. So next page. So now what we have to prove? To prove that H is a to prove H is normal in G. It is sufficient to prove that. So step prove okay. So next for all. So for all x belongs to 2. So that's for all x belongs to G. There exists. There exist two cases. Sorry. Okay. So two cases I put so not values. So on the G and consider matter. So G and the so next idರಲ್ಲಿ H and consider matter. Okay. So H another one consider. H another subgroup and consider matter. G another group and consider matter. So first from the X belongs to G. So the X one value. But next day form X does not belong to G again. X does not belong to H again. So X belongs to G. So X and value that belongs to G, but X that does not belongs to H. Okay. So you have cases of prove okay. You have cases of prove okay. So you have cases prove So here arises two cases. So first case number 1 Case number 1 when X belongs to G. Sorry, X belongs to H. Sorry, X belongs to G and X belongs to H. So anyway, two cases X belongs to H and X does not belongs to H. So therefore, the next one, therefore, X belongs to H, X does not belongs to H. Therefore, similarly, we can write that Hx is equal to H. Okay, means subgroup of H belongs subgroup of H X is equal to H. Therefore, we can say that similarly, we can say that X H is equal to capital H. Therefore, because so question is about so you sign therefore by the subgroup into one subgroup part that is H into H only, right, is equal to H subgroup therefore when H belongs to capital H. Okay, so same here also, same as it is. So H capital H is equal to H when same as it is H belongs to capital H. So this is how we write. Therefore, both the equations are equal. So you do values thus we can say that Hx is equal to XH or XH is equal to Hx. So XH is equal to H x ಅಂತ ಬರಬೇಕು. ಎರಡು ಬರೋದು ಒಂದೇ. Therefore we can say that h is normal. Okay, h is normal. This is how we prove the case 1. So next for this we shall go for a case 2 here. Next we shall go for a case 2. So we are having here case 2. Okay, case 2. We are in case 2 here. So what does the case 2 decides to do? So case 2 here. So therefore x does not belong to h. So now when the term what is that? So now here ಒಂದು h group ಇದೆ ಒಂದು sub group ಇದೆ. So g ಅಂತ ನೋಡಿರಿ h ಅಂತ ನೋಡಿರಿ. So ಏನಾಗುತ್ತೆ ನಾ ಆಗಲೇ ಹೇಳ್ತಾ x belongs to h. So x ಒಳಗದ x belongs to h, but that x does not belongs to g. So subgroup ನಾಗ ಇರ್ತದೆ ಒಳಗಿನ ಹೊರಗಿನ ಸೈಡ್ ಗೆ ಇಲ್ಲೆಲ್ಲೂ ಇರಲ್ಲ. Okay, but does not comes under that g. Okay, so we can say that directly ಹಿಂಗಿತ್ತು ನಾವು ಹೇಳೋಣ x h that does not belongs to capital H. Okay, same as usually h x does not belong to capital H. Okay, since we can write this, since there are only two distinct two distinct right cosets. Only right cosets and textbook left coset no ಕೊಡಲ್ಲ. Then we don't confuse about it. ಮತ್ತೆ ಇದು question ಹ್ಯಾಂಗ ಅಂತ ಕೊಡೋದು. Only right cosets ಅಂತ ಕೊಡೋದು. Right cosets ಯಾಕಂದ್ರೆ ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಕೆ only right cosets ಅಷ್ಟೇ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. Nothing about that. In cosets in h in g. Okay, h in g, these are. So next these are. So here ಎರಡು ಕೇಸಸ್ ಬಂದನು. One x belongs to h and x does not belongs to h. These are the two distinct right cosets. You can have distinct right cosets in that here. Okay, two distinct right cosets. So we can say that h and hx or and h and xh. So in textbook na again ಮಾಡೋಣ. So ಒಂದು right cosets ಕೊಟ್ಟರೆ next both are right cosets. So change for it. Then both are right cosets for it. Okay, or we can write this like this. So now first step only right there. First or second step I said that, sorry, in third step I said that g can be expressed in the union of these two right cosets. So right cosets ನಾವು union ಅಂತ ತೋರಿಸ್ತೀವಿ. union ಅಂದ್ರೆ ಅದು okay correct value. So we write h union hx is equal to g. H union hx is equal to g and h union xh is equal to g for all the elements of g sum cosets. Okay, so next ಇದು ನಾವು ವ್ಯಾಲ್ಯೂ ಕರೆಕ್ಟ್ ಸಿಗುತ್ತೆ. ಸೊ ನಮಗೆ cosets ಆಯ್ತು. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಂದ್ರೆ ಡಿಸ್ಜಾಯಿಂಟ್ ಅಂದ್ರೆ ಏನೂ ಇಲ್ಲ ಬೈ. So we can say that h intersection hx is null. Phi means ಏನು ಇಲ್ಲ null, and h intersection xh is equal to also phi. Then this is empty, disjoint. We can say that this is two are disjoint available. So you can say disjoint means it cannot be form a cosets. Can't form a cosets. You are a cosets form ಮಾಡಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. Okay, so for all from the above we can say that in normal from the above we can say that from the above, sorry, or you can write from the above, we can say that h x is equal to x h for all x belongs to G, for all x belongs to G. Hence hence h is normal, h is normal in G. Okay, h is normal in G. This is how we prove this value. Okay, so for the next I will say in the next class, means in tomorrow's class. So okay, today as if this is enough for this. From tomorrow I'll continue above two examples. After that, homomorphism and isomorphism. Okay, thank you.